Okay guys, so for section 2.7 we're talking about absolute value functions and transformations of absolute value functions. Actually just transformations in general. Once you understand transformations of absolute value functions, you should be okay to understand transformations of quadratic functions and other ones too. But we'll start with this fairly basic concept here of transformations. And I'll try and help you to understand this using Geometry Sketchpad, see if you can get a deeper understanding of how these transformations work. Okay, so objectives are to graph absolute value functions of this form. Okay, that's your standard formula for absolute value functions. And then after you graph them, compare them to the parent function. So the parent function is right here. Okay, y equals absolute value of x looks like this. Okay. Vertex 0, 0, and basically this side is the line y equals negative x, this side is the line y equals x. Okay, so parent function here. So once you graph a more complicated function, you have to understand what changed from the parent function to make the other function happen. Okay, and we'll go over some examples of that. And then you have to understand, what does a, h, and k do? Okay, changing the value a, h, or k in this formula, what do they do to the graph? Okay, and then we'll write some equations of absolute value functions, not very complicated, but something you have to practice, and then just applying a transformation to any function, a general function. Okay, we'll do others more specific things, but just a general function, see if you can understand what these transformations do. Alright, so we've already said the parent function is this, y equals absolute value of x. Okay, and so they just give you a little bit more of a description here. For the parent function, the vertex is always 0, 0. Okay, and so we want to look at some translations. All right, in this case, translations. So what does h and k do? What does h and k do to the parent function when you change their values? Okay, so basically it says here, translations are a subset of transformations. Transformations change a graph's size, shape, position, or orientation. Okay, but a translation just moves it left or right or up and down. Okay, and so the graph of y equals absolute value of x minus h plus k, right here, okay, is the parent function that's moved 8 units horizontally. So h moves the function horizontally, and k units vertically. So k here, if I change this value, it moves the parent function up or down. Okay, and I'll show you that in a second. So the vertex of this function is at h and k. Okay, it's at h and k. This is important stuff here. So the vertex of this function is at h, k as an ordered pair, not negative h, h. Okay. And so let me show you here, if I change the value h, so here's my function, y equals absolute value of x minus h plus k. Right now h and k are both 0, okay, so you can see that here. If I change h, this one, the textbook just said it moves horizontally, okay, so I'm going to change it here. Let's see what happens. So h becomes 1, 2, 3, 4. You can see that the parent function, okay, here's the parent function. The new function, y equals absolute value of x minus 4, moved over 4 units to the right. So when h is positive 4, my function still reads x minus 4, but h is actually positive 4. It moves the function to the right 4. Okay, let me go back to the beginning. So if h is 0, parent function. Okay. And now if I make h negative numbers, if h becomes a negative number, you see negative, negative 1. So actually this would read y plus 1. Okay, and so if h is negative numbers, the graph moves to the left. So left and right is what changing h does. Now if I change k, okay, the textbook told you here, it moves vertically. Okay, so parent function looks like this, y equals absolute value of x, but if I change k, it's going to move up or down. So if k is positive, my parent function moves up. If k is negative, my parent function moves down. Okay, so it says plus minus, but basically minus here. Okay, so that's what changing h and k does to my graph. And of course you can change both at the same time and come up with all kinds of interesting things. Alright, so the graph can move around in all kinds of different ways. So you can change h a certain number and you can change k a different number, and you come up with a completely different graph. So this function looks like this. Basically means I took the parent function, the red one, and I moved 3 units to the right from the vertex, 1, 2, 3, and I moved 4 units down, okay, from here, 1, 2, 3, 4. And so this vertex describes the change from the parent function to the new function. Okay, and if you can get that, then you pretty much can understand translation, okay, vertical and horizontal translation of an absolute value function. Okay, so let's go over here and try some. Let's go and try some. Okay, so how you graph them, you can either do it this way by understanding, or you can do it another way, and I'll show you the other way as well. Okay, so graph the function and compare it with the parent function y equals x, absolute value of x. So you have to tell me what changed from this function to the one we're graphing. Alright, and actually let me see if I can move this up just slightly. Alright, so let's try that. So we said the vertex, okay, the vertex is at hk. And so in this function, here is the formula, y equals absolute value of x minus h plus k. Okay, if I look at this, I say, oh, that means my vertex is at what? Now, you'll be tempted to say h is 4, but h is not 4 because the formula is x minus h. So what do I have to substitute into h here to get a plus? I actually have to substitute a minus in there. So h is actually minus 4. Right? So think about the opposite sign of this. H is actually minus 4. K is negative 2. Alright? To make this negative 2, I just substitute in a negative 2. So K is negative 2. This is my vertex. Okay? And so the vertex of the function is, let's label this x and y, negative 4, negative 2. Negative 4, negative 2, right here. Okay? So that's my vertex. And now I have to draw the function. Now the thing you have to realize, and you probably do know this already, about linear absolute value functions, is they're symmetrical. Okay, they're symmetrical about the vertex. So let me draw a line here and say this is the axis of symmetry. Okay, that's the axis of symmetry of my function. So if I have the vertex, okay, if I find a point over here, the other point on the function is reflected across that axis of symmetry. So I only have to find the vertex and one other point, and then I can just reflect it across the axis of symmetry to draw the absolute value function. Alright? So let's do that. That's the vertex. So let's just pick another point. So I'm going to say, let's pick an easy point. Let's pick 0, 0. Yeah, let's pick x equals 0. Okay, I'm just going to say what happens when x is 0. So I'm just going to say pick the point. Let's set x to 0. Set x to 0. Okay, and then let's see what happens to my function for y. So I take the function and I say y equals absolute value of x, which is 0, plus 4 minus 2. Okay, so what is y? Y is absolute value of 4, which is 4, minus 2, so y is 2. So when x is 0, y is 2, okay, right over here. Now I can use this information just to reflect this point across the axis of symmetry to the other side of the function. So I'm 1, 2, 3, 4 units away, so 1, 2, 3, 4 units over here, okay, and now I can draw my my absolute value function. Okay, basically something like that. Done. Okay, now that's one way. The other way is to look at the function and take the parent function and just translate it. All right. So if I just took the parent function, let me draw the parent function in a different color here. Let me do blue. Okay, so here's y equals x. Y equals absolute value of x. Okay, it looks something like that. This is y equals absolute value of x. If I take, here's the vertex, if I take that and apply the translation, I come up with my function. So this says, h says move me back 4, okay? This is positive 4, but actually we know that h is negative 4. So that means move back 4, and then if you look at the y value, it says move down 2. So move back 4, down 2. There's the vertex. And that's the transformation of the parent function. Okay? So you have to put that in words. Alright, so put that in words. So if I'm comparing this function with the parent function, I say, okay, what happened? It was a horizontal, okay, horizontal translation of how many units? So horizontal, how far did I move across? Left by 4. Left 4. Okay? So 4 units left. That's what happened. And then, okay, what else happened? So that's 1. That's the h value. This was a horizontal translation, 4 units left. But k was a vertical translation. Vertical translation, 2 units down. Okay, I went 2 units down. So also vertical translation, 2 units down. Okay? Alright. So, that's basically that. Alright, not much else we can say about that. So, let's go and do another one real quick. So, again, here's the function. The vertex is at hk. Okay? So, what's the vertex here? The vertex would be 2. Okay? H is 2 and k is 5. Now it's positive 2 because the formula is y equals absolute value of x minus h plus k. So this is the same way. Minus h will be 2, right? So h is 2 and k is 5. Alright? And so what does this mean? It means I translated the parent function 2 units to the right and 5 units up. Okay? Because h is positive 2 means go 2 right. K is positive 5 means go up 5. Okay? And so let's do that. If I go here, the vertex is 2, 5. 2, 5 will put me up here. 2, 5. Okay? Alright? And that's basically it. Okay? Now, you can go and be precise about this and all that kind of stuff, but this is the parent function. Okay? We're saying we took the parent function and translated it over 2 up 5. Okay? Over 2 up 5. So basically, if you continue with that idea, then my new function would be here. Alright? Very quickly you can come up with a new function. I just transformed it. It didn't compress, nothing else happened. I just moved it over and up. Okay? So that's the answer. That's done. Now you can go and do all the other work again like we did earlier and fill in the formula y equals absolute value of x minus h plus k, and you can fill it in. I'm sorry, we already have that. I'm looking at another example. No, that's it. So you've got that, but you can say this is the vertex, but you can try and find the other points. That's what I was going to say, okay? And so you can go down here and say, all right, if I find this point, I can use the axis of symmetry over here, okay, to find the mirror point across the axis of symmetry. And so that's what you can do. You can say, what happens when x is 4, okay? Let x be 4 and find out what's my y value. Now you should come up with this point right here, okay? So when x is 4, you get this, absolute value of 4 minus 2 plus 5. And so that gives me y equals 2 plus 5. So y is 7. So when x is 4, y is 7. So when x is 4, y is 7. That's the point we have. Okay? So 2 ways you can do that. use the parent function with the transformations, or you can actually find some points and use the vertex. And again, we've already described the change from the parent function. It's a horizontal translation 2 units right, and a vertical translation 5 units up. 2 units right, 5 units up. Okay? Alright, let's move on, and let me show you the next thing here that I prepared for you is what difference does it make when you have a number in front of the absolute value? Okay? So they give you all kinds of descriptions here. I'll just show you what happens, right? But it says basically here's a function y equals absolute value of y equals a times absolute value of x. So we saw in our objectives all the way at the top. Let me go back. We just talked about h and k, but there's also an a in play. All right, so we're breaking it down into simpler pieces, and then we'll combine it all together back again and talk about the complicated function in the end. All right, so the question is, what does y do to the absolute value parent function? So here's the parent function. Okay, let me move this over here. Here's the parent function, y equals absolute value of x. So what does a do if a changes? So right now here a is 1. Okay, a is 1. But if a changes, how does it change the function? So there's a lot of explanation here. But basically what it does is if a is bigger than 1, if a is bigger than 1, let's see what happens. Okay? If a is bigger than 1, you see what happens. Basically, this is called vertical stretch. Okay, vertical stretch. You're stretching the function so it's narrower. Vertical stretch. So if a is bigger than 1, it's a vertical stretch. Okay? And that's also what all this text here talks about. Alright, so what if a is less than 1 but bigger than 0? Okay? So if a is less than 1 but bigger than 0, this is what happens. Okay? So a is less than 1 but bigger than 0. It's called vertical compression. So vertically I'm squishing the function down and compressing it so it's flatter. Okay? So that's vertical compression. Now there's two other things that happen. What if a is negative? Okay? So you'll see what happens. As soon as a gets negative, the graph is reflected in the x-axis. So this function is now flipped over the x-axis. Okay? So that's what happens when a becomes negative. So I'll take it all the way to -1, and you can see it's a complete reflection of the parent function in the x-axis. That's what happens. Okay? And if you continue with that, you'll see again, if a is a number bigger than 1 but it's negative, it's still vertical stretch, but the function is reflected across the x-axis. Okay? And same thing here. If a is smaller than 1, okay, but negative, it's the same thing. Negative just means flip the function over the y-axis, over the x-axis, do a reflection. And then also, if a is smaller than 1, it's a compression. Bigger than 1 is stretch, smaller than 1 is compression, and negative means do a reflection across the x-axis. Okay? And so let me reset this back to 1, and you'll see it looks like the parent function again. Okay? So that's just a quick little display of what's happening here. So let me go and actually show you that. Right, so we'll just go ahead and look at that. So here's what I have. And so now the question is, what's the vertex? But nothing has changed. There is no h or k. The vertex is at h, k, but there is no h or k here. They're gone, so it's 0. So it's right here. Okay, that's the vertex. And so my axis of symmetry is here. Okay, my axis of symmetry is the y-axis. So x, y. This is my axis of symmetry. So basically, to figure out what's happening here, you just have to plot another point. Okay? Now it's difficult to do this just by looking at the function and saying how much it transforms. We just saw here, if a is less than 1, it should squish the function down a little bit. It's vertical compression. Okay? So it should make it a flatter function than the parent function. So the parent function looks like this. Okay? So this function should be flatter than the parent function. All right? And so let's go and find a point. So let's see what happens when x is 1. Okay? If x is 1, what happens to the function? So y equals 1/2 times the absolute value of 1. So y is basically a half. Okay? So if x is 1, y is a half right here. And if I use the axis of symmetry, I can put the other point here. So you'll see what happens here now is the function is compressed. Okay? It's compressed. So this is y equals absolute value of x. This is y equals a half absolute value of x. So the function got vertically compressed. Okay? And now this one, same idea. Here you can see it's -3. So the negative means the parent function, let me try and put this in a different color. The parent function, which is here, okay, the parent function, if it's negative, we expect a reflection across the x-axis. Okay, so negative means do a reflection across the x-axis, and we just have to figure out exactly how steep the reflection is. So the reflection is here from the negative, and then the 3, since a is bigger than 1, it will be a vertical stretch. Okay, so how much is it stretched? That's a hard thing to just kind of guess. It's more accurate to just find a point. So again, the vertex again here, hk is 0, 0. There is no hk. Okay, so a vertex is here, all right, for this function, and then just pick an x value. So let's say x be 2. Okay, so if x is 2, what is my y value? Y equals -3 times the absolute value of 2, which is -6. Okay, so if x is 2, my y value is -6. So down here. Okay, and this is the axis of symmetry through the vertex. So just go 2 over here. Okay, and so you can see that what happened here is the parent function, because of the negative, got reflected across the x-axis. Okay, and because of the 3, it's vertically stretched. Okay, vertically stretched. So smaller than 1 number but bigger than 0 compresses vertically. Bigger than 1, okay, the a number is bigger than 1, is vertical stretch. In this case, it's a negative in front, and that means a reflection. Okay? All right. So now let's try something. Oh, yeah, I think we just covered all the description there. Now let's try one that has everything applied to it. Okay? Here we have y equals a times x minus h plus k. Okay? So all of the values have been changed. So in this case, my a is -2, my h is 1, and my k is 3. Okay, be careful, h is not -1, it's 1. Okay, here my h is -1. Alright, any case, so let's look at that, and they're saying again, graph the function, compare with the parent function. So let me draw the parent function right off the bat. Here's the parent function, y equals absolute value of x, y equals absolute value of x. Okay, compare this function with this function. Let's see what happens. So I know h means take this and move it over 1, and k means move it up 3. Okay, so there's my new vertex. That's what these two things do. Horizontal translation 1 to the right, vertical translation 3 units up. Alright, and now I can almost graph my function, but the problem is I have the a value that's making a vertical compression or stretch. In this case, the number is 2, so it's vertical stretch, so it should be a compressed graph, and because a is negative, it should be reflected across the x-axis. Okay, so let's see what happens. I'm just going to find a point. So the axis of symmetry for this function is through the vertex here. Okay, so if I find one point, I can just plot the other one by mirroring it across the axis of symmetry. So let's just pick an x value that's not this one. So let's say x is 2. Okay, so let's let x be 2 and see what happens. If x is 2, I get y equals -2. I'm working from the original function, times 2 minus 1 plus 3. Okay, so if x is 2, what I get is y is 1. Okay, so this is 1, absolute value of 1 times this is -2 plus 3, which is 1. So when x is 2, y is 1. So when x is 2, y is 1. Okay, and across the axis of symmetry, I can reflect it this way. And so we can draw our parent function, come over here. I mean, not our parent function, sorry, this is the parent function. We can draw our new function, okay? And so this is the new function, okay? And so you can see what happened is vertical stretch, okay? This 2 here caused a vertical stretch. The negative made it flip across the x-axis. This 1 made the parent function move over 1. This 3 made the parent function move over 3. Okay, so I moved over 1, up 3, flip it across the x-axis, and it's vertically stretched. All right. Okay, let's try one more here. So again, I have this. In this case, they use function notation. A times absolute value of x minus h plus k. So let's identify the values. A here is -3. X minus h. H here is -1. Okay? Because negative makes a positive 1. So -1. And then k is -2. Okay? That's k. Okay. So this tells me if I take the parent function, the vertex has moved down 1. Okay? Has moved to the left 1 and down 2. Okay? So left 1, down 2. That's what h and k do. Okay? And then I need to find another point to see exactly the impact this has. So we know that the negative a value should do a reflection across the x-axis. So instead of opening up, it's going to open down. Okay? And the 3 is a vertical stretch, so it should also be a bit narrower than the parent function. Okay, so let's try that. Let's find a point. So here's my vertex. Axis of symmetry should be here. Okay, and so I just find one point. So let's say what happens when x is 0. That's an easy one. Let x be 0, so I get f of 0 is -3 times 0 plus 1 minus 2. Again, I'm working from here. Okay, substituting the 0 there for x, and so f of 0 or y is -3 minus 2, which is -5. Okay, so when x is 0, y is -5, which is down here. And use the axis of symmetry to find the other point. And so we can draw our function. Okay, so it looks something like that. Right? So you know now the parent function, you know very well, looks like this. Okay, there's the parent function. And so here's what our function looks like. Alright, I think I've beaten that to death. I've basically told you exactly what can happen there. Not much more I can describe there. I'll make this activity available to you guys in class so we can mess with this and you can experiment and try and figure it out. Okay? Alright, so now the fourth and fifth examples are supposed to be a bit simpler. This one is write an equation of an absolute value. So they give you the graph and they say write the equation. Alright? So basically how you start this is to look at the vertex. So the vertex here is at 4, 6. So 4, 6. Now I have my formula, y equals a times absolute value of x minus h plus k, and I just said that this is h and this is k. Okay, so I can plug those two in. Problem is I have x minus 4 plus 6, but the problem is I don't have a, so I need to find a. So you can pick any point on the graph, any point on the absolute value graph, and use that to help you find a. Okay, I'll show you how. So I'm going to pick this point right here, which happens to be 0, negative 2. Looks like an easier point to me. Okay, and so you plug that in for y and x. This is a y and an x value. Substitute that in. So this is y. Leave a. I'm trying to find a. X is 0 minus 4 plus 6. Okay, and simplify this, and that gives you a. So negative 2 equals, if you simplify this, you get absolute value of negative 4, which is 4a, plus 6. If you simplify that whole thing, you get a equals negative 2. Okay, subtract the 6, divide by 4, a equals negative 2. So now we've actually found the entire function. Okay, let's write it in blue. So y equals a is negative 2 from here. Okay, y equals negative 2. Absolute value of x minus h is 4. They gave it to us right off the bat, plus k, plus 6. Okay, so this function gives me this graph. And you can check yourself, right? You can check yourself and see, is that correct? So I've set up a little graph here, and I say if I make a negative 2, okay, so let's make a negative 2. Alright, and if I make my h 4, sorry, yeah, h is 4, that's right. And if I make my k as 6, okay, that's the graph I have here. Right, exactly the same graph I have here. So that worked. What I did is correct. And you can see the difference from the parent function. Okay? Alright, so let me take this annotation off here, and let's do another one. So again, first thing I can find here, if I want to write the equation, is my vertex, my h, and my k. H here is negative 4, and k here is negative 2. Okay, that's my vertex. And so same thing, fill in the formula, y equals a times absolute value of x minus h minus negative 4 becomes positive 4 here. Plus k, k is negative 2, so plus negative 2 becomes negative 2. Okay? So that's my function so far. I need to find a. Again, pick a point. So let's pick this point on the graph. That would be x equals negative 1 and y 0. That seems like an easy point. And plug it in. So y is 0 equals a times absolute value of negative 1 plus 4 minus 2. And simplify this. Okay, so 0 equals, what's that? Absolute value of 3, which is a, 3a minus 2. Right? Move it over. If you simplify this, you find a is 2 over 3. A is 2 over 3. Okay? And so you can see here, if I look at the parent function, this has actually been vertically compressed, and that's because of 2/3. Right? 2/3 is smaller than 1, bigger than 0, and what that does is vertically compress the function. Okay? And so that looks correct. So if you fill this in to find the final function, y equals 2 over 3 times absolute value of x plus 4 minus 2. Again, you can put this in your calculator or something and graph it and see what you come up with, or use Geometry Sketchpad, but this is the correct function. Okay? Alright, I want to get through this because this has been a fairly long set of videos. Alright, so let's quickly finish this up. It says, now that you understand transformations, all right, hopefully, it says try and apply this to a general function. So here is a function, you don't know what it is, it's just called y equals f of x. Y equals a function. Okay? And it says, what would it look like, each point, what would the function look like if I change the a value to negative a third? So in this case, to find out what that means is y equals f of x, this whole thing means the y value. Okay? The y value. That's what y equals f of x represents. Alright? So if x is 0, if I plug in a 0 here for x, my y value comes out is 0. Okay? And so to find out what this does, the x values are not changing, but the y value will change by a factor of a negative a third. So I just pick some points. Now 0, 0 is not going to change. If I throw in 0 here, what's negative a third times 0? It's still 0. That's not going to change. But these 2 points will change. So basically what you do is you say this, okay, here when x is negative 3, the y value is negative 3. So you substitute that in there. Okay? F of x is negative 3 here. So what does that give me? That gives me positive 1. Okay? So at this point, x is not changing, but y is changing to positive 1. Okay? So that would be this part of the function. Okay, let's see if I can clear that up. That does not look very good. Okay, so here, and let me use this thing. Okay, from here to here. That's the new function. Alright, the new part of the function. And then this side, if y is negative 6, how does that work here? So negative a third times negative 6 here. Okay, and so that gives me 2. So the x value, again, nothing's changing for x here, just goes up all the way to 2. Okay? So that would be the new function. So if I take this function and I multiply it by negative a third, this is what I get. Alright? Alright, same question, same function, but a bit of a different question. These are translations. So this was compression. If you look at that, you could have seen there was some compression going on there. Okay? Because it's negative, it's flipped across the x-axis, and a third means vertical compression. So it's squished down. That's what happened there. So this one, what I expect to see is move to the right one and move up 3. That's what this is telling me. Okay? Because h and k here are 1 and 3. So basically what I'm saying is, take this function and take every point and move it to the right one and then move it up 3. Okay, so move this point to the right one up 3 gets me there. Okay, move this point to the right one up 3 gets me there. To the right one up 3 gets me here. Okay, so my new function should look like that. Okay. If I take this and I apply the transformation, or actually it's a translation, move over 1, up 3. Okay guys, so I hope you kind of have a sense of what h and k and a does to a function. And we'll be looking at this in an activity in class on our next class period. Thank you guys.